Oh, you're like the brightest person I know.
Should I put on another light?
I don't know.
Hello.
This is my problem. Is that like my options
spooky.
are this,
Blair,
or this?
Yes, we should be telling Halloween stories with your dark lighting.
This lighting blows.
Hey everyone, we are here with our lighting issues, with our...
Oh no. I'm glad I said blows.
You did say that.
It's fine. It's normal words.
Yeah, I almost said something else. I'm glad I said blows.
What would you have said?
Oh, I don't know.
This was a good word for public facing like we are right now. We try to be family friendly. We do this show for you, your family, your friends. We hope you're all sitting around that nice warm, ooh, not a campfire. It's like 100 degrees in Portland right now. How's that heat dome, everybody? There's heat and fires all over the place. I hope that wherever you are staying cool, staying sane, and getting ready for the science.
That's right.
Yeah. We all ready?
Yes.
Yeah. This is when you check the microphones and say the words.
Oh, testing. Check. 1, 2. Is it on? Can
Yes.
people hear me?
Thank you.
Okay.
Blair.
Hello. Welcome. I'm excited to talk about things.
Thank you. Yes, I am glad you are excited. I am glad you're excited. I'm excited too. Let's start the show.
Woo.
Everybody, are you ready? Beginning the show as soon as I open my iTunes, because I had not done that yet. It's a good thing to remember to open the iTunes when it's time for the music for the start of the show. We're starting the show in 3, 2. This is TWIS. This Week in Science, episode number 837, recorded Wednesday, August 11th, 2021. Do you have climate concerns? Hey everybody, I'm Dr. Kiki, and tonight on This Week in Science, we will fill your head with bargain shoppers, freeloaders, and maniacs. But first...
Disclaimer. Cause and effect. Poke a beehive and you get angry bees. Load the atmosphere with carbon, you get a greenhouse effect. Fail to take a contagious virus seriously, you get a surge in hospitalizations and death. Everything happens for a reason. Which begs the question, what is the cause of people who are ignoring global warming and COVID-19 precautions? In the case of global warming, it's pretty obvious. The fossil fuel industry is the major contributor of carbon emissions, has funded marketing campaigns against science, and is a major contributor to politicians who refute science, despite the fact that it threatens so many lives if not dealt with. Cause and effect. We saw this in the past with the tobacco industry, when big tobacco was paying politicians and marketing campaigns, and they were funded to keep people smoking, despite all of the health risks. But what about COVID-19? What causes campaigns and politicians to refute the science, despite the fact that there are so many dying as a result of it? Well, the answer isn't yet clear. It one day maybe will be. And I'm guessing it's institutional real estate investment syndicates, but we'll see. Despite causing and profiting from disinformation that directly and predictably leads to the deaths of thousands, they will get away with it. Like the oil industry, like big tobacco, and just like This Week in Science. Coming up next!
I've got the kind of mind that can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We have returned with our binders overflowing with science.
Our pockets full of napkins with quickly jotted notes that hopefully we can read later.
Yes, exactly.
Our hats full of rabbits. No?
No.
That's not on the list.
Oh no.
I don't know. Unless you want to
Blair.
join my underground resistance, I've decided that everyone has to wear bunny masks, and we're going to call it the Warren.
Oh, that sounds like fun.
It'll be fun. It'll be great. Do you want to join?
Can I go full bunny costume?
You can go full bunny. That's
What
great.
if I show up
that's fine.
dressed as a fox?
Ooh.
Blair. We'll
Way to
find a
fish for
place for you.
compliment.
That's fine. That's fine. Welcome, everybody. We do actually have a lot of science for you tonight. I brought stories related to, that climate thing that's been going on. But I also have some freeloaders. I have also chimpanzees and little lady mice. Justin, what do you have?
I have a mystery on Mars. Why the Matrix first pitch? Not the movie that got made, but why the first pitch of the Matrix movie may be coming to a reality. How to reverse
Intriguing.
aging through microbiota. And a potential reversement or cessation of mast cell cancers.
Oh.
Cancer cure treatment, possibly.
Interesting.
On the path to opening a door to a venue that may one day exist.
Yeah. We won't say a cure now, but maybe it's putting us on a path. Yeah, we'll talk about that. All right, Blair, what is in the animal corner?
Oh, in the animal corner, I have bats and frogs, but also I have a quick story before that regarding maniac robots.
So it really is Halloween in Blair's animal corner. Never mind that we were in the middle of August.
It's always Halloween here.
Well, I'm looking forward to all of these stories. Every day is Halloween, right? As in the name and lyrics of the old song. But if you have not yet subscribed to This Week in Science, you can do that very easily looking for us. All places podcasts are found. Look for This Week in Science. We are also on YouTube, Facebook, and Twitch. On Twitch, we're TWIS Science, TWISCIENCE. Same name on Twitter and Instagram. And our website is twis.org. All right, on with the show. Let's dig in to some of the science. Okay, I didn't want to talk about this story because we really talk about this subject all the time on the show. But this really is the biggest science report of the week. It is the 6th International Panel on Climate Change Assessment Report that was released this week. The IPCC has released a report analyzing over 14,000 scientific studies. Over 700 scientists volunteered to input information, to write the report, to assess all of this work, and to boil it down into something understandable for policymakers. And I mean, if you've never listened to TWIS before and this is your very first time, welcome and hello. But additionally, you might not know as much as everybody else who listens to the show regularly about the dire straits that we are in, pretty much. But the long and short of it is that there were a few updates to this 6th assessment report. Things that hadn't really been talked too much about before, regional differences in how climate change is going to affect different areas. So, for instance, the Pacific Northwest burning a lot more and getting hotter and having less precipitation. Same for California. But other areas getting a lot more precipitation, winds changing, coastal areas being affected. So the regional aspects of this report are very, very insightful and should be useful to policymakers in regions around the world.
So what's the good news?
Okay, well, the take home is...
Is there any?
The take home is...
Taking a no.
Climate change is here. And it's our fault, and we need to reduce our carbon dioxide. And there are a lot of other greenhouse gases involved, but basically, if we can reduce our carbon dioxide output to at least the Paris Accord levels, if we can do it more than that, that's great. But if we can reduce our carbon dioxide output, then we will be on track to limit the amount of warming that takes place in our atmosphere around the globe. We will be on track with that, with reducing the extent of warming to reduce the impacts of all the other climatic effects that will occur.
That sounds great. If we reduce, we'll do better. How much do we have to? What is the level of? What is the urgency?
Well, right about now, we are on track for about 3 degrees worth of warming, and that's more than we want.
That's more than we had initially been talking about at this point. Like when we were first talking about this many moons ago, it wasn't that. It was like, 1 degree by the end of the century. Now we're talking 3.
Right. Yeah, we're about on track for 3 degrees. Give or take a few. There are always errors baked into this because there is a bit of uncertainty.
Every time though, we've only gotten more degrees. They haven't been like, we're taking one off. It's actually,
that's not true. They actually, in one of the midterm reports that came about, there was an increase. They thought we were going to go up to 4 to 6 degrees of warming, but they've since dialed that back, and now they're looking at, like, right now it's about at 3.
So we should just wait for the next report.
But 3 degrees of warming is still going to lead to
really bad
triggering cascading effects, because we will reach the thresholds within the climate that will lead to things like, ice shelf instability, that will lead to massive amounts of ocean level rise, to the ocean expansion that occurs with heating. There are going to be biological effects that affect life on the planet. Forests are going to retreat. There are going to be more fires. The more forests retreat, that means less habitat, less ecosystem, and less ground cover that produces wonderful clouds that has a cooling effect, less carbon storage. There's all sorts of things, more desertification, like bad stuff. But I don't want to focus on the bad stuff, because that can just get us dooming and glooming, and we'll be like, ah. But what I found really, I guess, inspiring from this is that things are a much more certainly known factor at this point in time. Where it used to be a lot more debatable, it's not anymore. We did this, and it's in our power to stop it.
I think it's interesting. Like the IPCC report, the first few that came out, you had to really be clued in to science to even hear about it.
Yeah. And
I even remember the 2016 presidential election. Climate change was not spoken. Those words were not spoken in the presidential debates.
Oh, 2008 Science Debate got started, which is a nonprofit that tries to get the debates to include science in the questions. And they fought really hard and could not get climate onto the debates in 2008. But since then,
Yeah, I mean, everybody's talking about the IPCC, and nobody knew what that was 5 years ago. So awareness is the first step, and we've made huge strides on that. So the next step is to get people to buy into kind of what it's going to take. But of course, the problem is you need to get people to force the powers that be to buy in, because really it's not up to the individual. It's up to the community, and it's up to the system. So I could say right now I want to buy an electric car, but I don't have a place at work or at home to plug it in. So that's kind of
right. And then where is that electric power coming from for the electric car? There are so many factors. It is a large and complicated problem. But there are solutions. One study out this week, John Timmer over at Ars Technica wrote about an assessment looking at the dirtiness of power generating plants around the globe. And, you can think, coal power plant, probably pretty dirty. But some were built a long time ago, are not very efficient compared to others that are more recent and have more recent technologies. So the assessment found if you got rid of the 5% of the dirtiest power plants around the globe, that would take care of about 75% of the emissions from power generation.
Whoa.
Just the dirtiest plants. If we can get we're passing an infrastructure bill right now. If we can get our infrastructure bill and others moving forward to support decommissioning inefficient power plants or making them more efficient, adding carbon capture. Another aspect that they calculated was that if we were to put carbon capture on a lot of these dirty plants, it would substantially affect the amount of carbon dioxide that is released into the atmosphere during the power production process. So there are things that we can do that are solvable, that are like right here, right now, this is something we can fix that'll have a major impact, because one of the places that we have the largest amount of emissions is in just the generation of power that we all use, that everybody uses. That's a massive impact just by cleaning things up, getting rid of the broken toys, or fixing them. Let's upcycle, everybody. That's good.
Why does my car have to be smogged, but these power plants don't?
That's a really good question. Why are we working with old technology when we should be updating our infrastructure in such a way to make it work better for us?
And the answer to your question, Blair, is because the power plant is not in your backyard. It's not in the valley. It's not in the city that you're not seeing the pollution. So that you take care of. But the thing you don't know that's going on, you don't see, you don't smell, isn't affecting your air, you just completely ignore. But this is one of those points when we start to realize, oh yeah, everything has effects on everything else. So even though you can't see it and smell it, maybe that power plant is absolutely still affecting your environment. I'm still kind of curious about that statistic. I don't know if you have the drill down on it, but the 5% of poorly efficient ones. I'm wondering how much energy are they putting out? Because if they're inefficient and they're the same size as everything else, they could only have maybe 1% of the energy output of all of them. But if they're that 5% that's old and inefficient are the biggest behemoths, they could have 20-30%. So that's the kind
I think it depends on where you're talking about, like which plants you're talking about. Some of them are really big old plants. Some of them are smaller, But
just wondering what that 5% produces even. Compared to the rest
the total amount of megawatt power production by those plants.
That's where you could decide maybe instead of spending money retrofitting anything or upgrading anything, shut them down and just build municipal solar power plants or something. Put solar panels up instead of.
So solar is another direction, wind is another direction, but as we've seen also from the infrastructure bill, another direction that is being funded that I haven't heard talked about in quite a long time, but seems to be, it's been percolating and is coming back up, is the hydrogen economy. And within the infrastructure bill, there is money that looks to be set aside for research and development into regional hydrogen hubs, and also into creating a cleaner hydrogen economy. Because one of the issues with the hydrogen economy at this point is that it's still dirty. We're making our hydrogen from methane, and it releases a lot of methane in the process, and there's other byproducts. And so there's a lot of greenhouse gases still involved, and it's not clean. The hydrogen that we're using is not necessarily clean power. And the ways that we would get the hydrogen cleanly are still expensive. We don't have the right kind of cheap catalysts at this point, or they're just dirty. We don't have other ways to make it. There's a type of turquoise hydrogen that is being discussed at this point in time, green hydrogen and turquoise hydrogen, that are cleaner, but they're still not just hydrogen from water. There's electricity and electrolysis and a lot of energy that goes into producing the hydrogen in the first place. But hydrogen itself does have the potential to drive a shift in our energy economy. So that's something that's being invested in currently, which is interesting.
I think, I have a strong opinion about this. I think pursuing hydrogen is dumb. It's a false choice. Wait until the animal corner. This will make sense. It's a decoy. It is 100% something that they're like, oh, you don't want to go full green. Well, what about this option? Then you can still pump gas. Then you can still it'll be similar, but it's a little better. So wouldn't you rather do that? And it's just rip the Band-Aid off and go for clean energy. I do not understand why we're not. It's frustrating
because I think,
to me.
it's frustrating. And I think you're right, because one issue within the whole green economy, sustainable energy sector is greenwashing. And that's the idea that companies say it's going to be so much better and it's going to be helpful. And, the other natural gas, it's a transition fuel. It'll keep it going. But oh my gosh, it's warming our atmosphere very rapidly as well. We're extracting it.
And polluting water and causing earthquakes.
Yes.
and making land fall.
Yeah.
There was somebody, the people who advertised for hydrogen gas is so genius. I bet if you asked a random person, they would say oh yeah, water vapor comes out of the tailpipe. Perfect. That's not the whole story.
No.
Wait, there's more? Well, I've always sort of also had this picture of you pull up to the electric plug-in for your car, and as soon as you plug it into your car, you hear behind the concrete wall, you hear a diesel generator fire up.
Right.
All they've done is connect that to something that's burning fossil fuels. So having an electric car when your town is electricity comes from a coal power plant isn't the solution. It's sources.
It's better. It's still better. But that's the conversation, right? No,
I don't know that. I don't know
actually
that.
is.
It depends on that plant. It isn't, because if that plant, if that plant is burning coal without any sort of exhaust system, right? If it's polluting, burning coal, that's the same as driving a car that has coal.
It's not the same.
It's the same
No,
thing.
it's not.
It actually is. Maybe it's worse.
All right. So right now, the U.S. Secretary of Energy, Jennifer Granholm, has launched the Hydrogen Earthshot program, which is a program that is aimed to create, this is technology agnostic, aimed to create greenhouse gas free hydrogen production at $1 per kilogram before the end of the decade. And if they fund it, if they fund the R&D, if they fund the experimentation, if they fund also the small batch tests that need to occur to help, like they did with solar and with other technologies, if they subsidize it to help it get to a point, it is possible that hydrogen could be clean and inexpensive. But
yes,
it's not yet, and that is the big point, and we all need to be aware of the greenwashing effect and whether or not that is happening, and we need to hold our government and the researchers and the companies who become involved in this to a very high standard, because this is our future and we can do this.
Yes. It's as the my very first climate change summit I attended when I started as a little climate change educator so many years ago said, it's real, it's bad, it's us, but there's hope. There you go.
Yeah.
And I will also say there are several studies. I dropped the links in chat that said that
chat room says Blair's right.
Is 100% funded by or powered by a coal grid. It is still cleaner.
Of course, I will point out, talk about greenwashing, you did pull up a Forbes article. So I'm just saying, if you're going to greenwash, that's where you would do it. Like, that's That's exactly
All
There's
right.
multiple
who you would go
citations.
to.
It's fine.
Get that out there.
Triangulate your research, people. Multiple citations. Don't just.
And there are 3
don't
in
just
there.
use one. Yeah.
Okay. Yeah,
Okay.
there's more. Chat room
Justin,
agrees with you. I agree with you. That's how it
Let's move away from solutions to this climate conundrum. And I want you to tell us about a mystery that popped up this last week.
Yeah, so it's not a local mystery. This is taking place on Mars. And as of right now, from what I understand, they don't really know what happened. So Perseverance is a little rover up on Mars, and it's been outfitted with a bunch of little core sampling devices. So it's automated, and you can go around, and it's going to drill into the Martian soil, and it's going to take these rock cores and just deposit them, right? Later, there's another mission that's going to come and pick up these rock cores and then bring them back to the Earth so we can study them. Very fascinating. So they had their first run, and they did they kind of brushed away, the robot brushes away the surface dirt a little bit to get down to the rock underneath. Runs this core in, pulls it out, points the camera at where it drilled. There's the hole. Then it goes looking for the core, and it's gone. It's been swiped. Something has taken the core. Or maybe something else is what's happening. But they have the core itself is empty. The hole is there, but there is no little deposited rock core on the ground anywhere. So they're still trying to figure out what happened. They think there was some sort of reaction with the atmosphere. It may be that the rock core that they were grabbing was a lot less solid than they thought, and it's basically turned to sand or dust and just blown away once it was removed. The fun part is they really don't know. And this is so far 0 for 1. I guess this is they took one shot and it's already failed. So hopefully we will get to keep trying and get some of these cores out there so that we can have this other mission that's already planned to come pick them up. But right now, top people at NASA, are working on this.
Isn't the highest probability that it was just dusty and it just crumbled away into
that's what I was
dust?
Thinking.
That was my initial you got something that seemed solid enough for the rover. Fine, the driver didn't sink in or anything like that. Solid enough that when you were drilling it, but just kind of if it was sand, basically, or even some kind of a limestone kind of thing that even your drilling was enough to powderize it. Then maybe that's all that happened.
I feel like we need to have, what is it, scorpions?
Scorpions? Wait, what are you whistling and saying scorpions for?
I don't know. There's what's this? Maybe I'm conflating two 80s songs. It's like blowing in the wind kind of things. Anyway.
But here's the other thing.
Sounds like Dreamweaver is what you were saying. What you're whistling.
There was another. We sent a scorpion. We sent a mole. That was the. We had I can't remember what it was called, but there was something called the mole.
NASA Insight.
Insight, thank you. Insight was supposed to be like a little burrowing robot that was supposed to, but couldn't. It kept trying to burrow, but for some reason just failed.
The ground was too hard. They couldn't get into it. Where they landed, they thought it would be good, and then it wasn't. And Insight doesn't move, so they're doing other things there. They had backup plans. It's doing other things.
They should send something over and just drag the mole over to where Perseverance is, and then see if it can do its job. They'll just switch spots. See if that works.
Yeah, what I think what is really fascinating is, we're not there. It's a robot. We're looking at things through cameras, and the robot's like, I thought I had a core. I don't have a core anymore. What's going on? And all we have is the visual evidence. So if we don't have the video of all of the dust blowing away as the core sample was taken, how does it solve itself? But you never know till you get there. So it's a rover, and it can go someplace else, and it can dig another place.
Well, it will. But the thing I didn't realize that I learned from the story too is that, or this event, is that it's completely automated. It's not getting instructions to dig. And apparently, I guess there's no manual, because the first thing I would want to do is just dig. Let's dig here again. Let's dig here again, and let's see if we can get some remnant of this thing.
So it's automated, but it's not like it decides completely by itself where it's going to dig.
I thought it was.
People here on the planet people here on Earth are like, this is a great place to start, and they hit the go button, and then the robot has all the stuff installed. It has the instructions to know how to start the process, and if it's going to pick up the core sample and move on a certain distance to another location and dig again, it has all that information and can do it completely autonomously. Yeah. I'd
hit the go button right away. I want to see. I want to know right now what are we working with? What is happening?
Dusty ground.
Yeah, because if it was just sand type thing, then they wouldn't have the hole necessarily. Like, it's got a nice, it's right where the core was. There's the hole there.
Another rover came over and kicked it out of the way, obviously.
Oh, yes, obviously.
Obviously.
This is just a lesson that the next time we have a rover that's going to be taking core samples, that we need to have it equipped with a little spoon as well, so it can just shovel up anything that it drops.
And some milk. Don't forget the milk.
Don't forget the milk. All right, Blair, what do you have for us? Yeah, what did you want to talk about?
I have tiny robotic maniacs that can climb slopes, move against fluid flow, and deliver substances to your neural tissue.
Nope. No thanks.
Do you want a little maniac in your cerebral spinal column? No?
I already have a maniac in my cerebral spinal column.
Well, if you didn't know, maniac stands for magnetically aligned nanorods in alginate capsules. So
I did not know that. Thank you.
I did.
It's just Eddie. Let's name it Maniac. Anyway, maniacs, magnetically aligned nanorods and alginate capsules, might be part of an advanced arsenal of drug delivery technologies in the future. They can be controlled by a magnetic field. They are little tiny tumbling soft robots. It's important that they're soft so they can move across tissues and against fluid flow. They can climb slopes, so they're like a little picture a barrel kind of rolling uphill. So they can climb slopes, and they can move around neural tissues like the spinal cord without hurting it, and deposit substances at precise locations. So obviously delivering drugs orally or intravenously is difficult. It's difficult to target specific things like cancers or neurological diseases in neuronal tissue, because then you're kind of delivering it systemically. So that might affect regions elsewhere in the body or other parts of the nervous system unrelated to the disease. So really, to be able to deliver drugs to the exact precise location in the nervous system is really important. And so that could help lead to improved efficacy. It could reduce side effects. It could even help with re-administering drugs that normally you can only administer via crazy surgery. So the main problem to this point with using robots for this is in controlling their activities as they travel through tissues in the body. And so this tumbling robot helped them see how they could handle moving across real tissue. They have these magnetic nanorods. They're encased in soft spherical shells, and they are being controlled by an external magnetic field. So you can go to a very specific site for drug delivery. They tested them climbing slopes with increasing steepness and moving against flowing liquid. And then the last step is they actually obtained rat brains and mouse spinal cords to test their ability to move along those tissues. They deposited dye on the surface because obviously if it was a dead rat or a mouse, there wasn't a lot of point to administering drugs.
But it could have been a real drug.
Yes, yes.
That's proof of concept here. Yes.
Exactly. So this is obviously very preliminary, very experimental, but they think they've demonstrated strong enough evidence that small, soft, capsule-based micro robots, maniacs, have potential for controlled local delivery of drugs in neuronal diseases. So, I just thought it was very cool. Nanorobots in drug delivery, for some reason, I know I'm like afraid of some technologies and robots doing things, but this seems perfect to me. I've always been very intrigued by the nanorobots for drug delivery. I think it's great.
I like the very targeted aspect of these kinds of systems, where it's not just going to be all over the body. I mean, that's one aspect. It could go everywhere and deliver a drug everywhere and get into all the nooks and crannies and crevices that it needs to in your body. But the other aspect is like this, magnetically controlled. There have been others that have been controlled in different ways, but being able to target them to very specific areas for very specific therapeutic solutions is that, I think, makes it gives it a lot more sense. I was trying.
Rick in the chat room. Go ahead.
If you think of how we treat a cut, if we did it as systemically as we take drugs that go everywhere in the body, you get a cut on your finger and you're like, quickly wrap my entire body in gauze. Yes.
Yeah.
This is the solution because it's the only thing we know how to do.
Yeah, every pill
it's
you
ridiculous.
take.
It's utterly ridiculous.
And so this is exactly the idea. Rick Loveman in the chat room says nano epidural anesthesia. When we give epidurals to people who are giving birth, usually their legs go numb. Wouldn't it be nice to be able to deliver it so specifically down to the nerve where that would not be the case?
Yeah, and also to reduce the possibility of paralysis because you're so specifically getting into a location.
Yes.
It's never made sense to me. I mean, I get you want to. The pain is bad, but don't you need to know don't you need some to be able
That's
to push
a whole
and stuff?
different conversation.
Okay,
Completely different conversation. Yeah, this is fascinating. Little maniacs in the CSF.
Yeah. Inject me full of nanorobots so they can deliver the drugs exactly where it's supposed to be, exactly when I need it. That sounds great.
That sounds fantastic.
Yeah.
You know what else sounds great?
What?
Reversing our ages. What if we could go backwards in time? Yeah. Tell me, Justin.
So this is actually not going to seem too incredibly earth-shattering to longtime listeners. But the microbiota regulates a lot of human immunity and brain health, we have been finding out over the years. As humans age, there are dramatic alterations in our immunity and our brain health, but also in our microbiota, which is linked then to that poor health and elder populations. So we know that there are connections between gut microbiota and our health, but we don't exactly know the mechanism. We don't know all of the things, the levers that are being pulled, the chemical communications that are taking place. So scientists kind of went and looked at some things to study some of those solutions for human health in mice. This was a mice study.
Not a people study.
Not a people study. What they did is they did the fecal microbiota swaps. They transplanted either from a young mouse, 3 to 4 months, or an elderly mouse, which was 19 to 20 months old. So the older mice, they put the young mice poop in the old mice, and lo and behold, there was age-associated differences in peripheral and brain immunity, as well as hippocampal metabolome and transcriptome of aging recipient mice. So the old mice started to get the effects of youth just by being filled with the fecal transplants of the aging mice. Finally, the young donor derived microbiota attenuates selective age-associated impairments in cognitive behavior when transplanted into an aged host. So basically reveals that they're actually saying this might be just stop there. We may have found a suitable therapeutic target to promote healthy aging. So they stopped short, in at least the abstract here, of saying, okay, we understand the mechanism now, and just went, we should just do this. Mm-hmm. We should just, why aren't we doing this in humans to study them?
Sign me up immediately. Yeah. It's the fact that we don't have poo pills yet in modern medicine.
They do exist. Dr. Justin is not a real doctor. Poo pills are still on the market.
No, it's honestly, this might be a little too much personal information, but I was having a lot of stomach problems recently, and I went to the doctor, and at no point did the doctor want to look at my microbiome. And it's not part of common practice yet, and I think it's insane.
Well, we don't really, it's not part of common practice for assessing general gut microbiota population makeup, because everybody is different, and if they don't have a before you had problems sample, it's hard to know what exactly is off. They could do a sample to determine whether or not it's, you have an overgrowth of a more toxic bacteria, for example, but that then still doesn't get at what the cause of that problem is.
I think they take
but
the
you're
sample
right.
annually.
It's not enough yet.
They track your microbiome, and then when you have problems, any problems really systemically in your body, they can check that and see if the balance is off from when you were healthy.
Yeah,
I think the issue is that they don't have they still don't have diagnostic information backing them up. So with a liver enzyme, there's a whole sea of papers that have been developed that say, okay, if your liver enzymes are doing this, or you're doing that, or your blood cell count is this versus that, here's what might be going on with our patient. But the microbiota is still like, well, that's interesting. Here's some interesting information.
Yeah.
There you go. Have at it.
But so instead of possibly having a fecal transplant, which they do use therapeutically in some situations for people who have really extreme bowel issues, chronic bowel issues, what can we do? I mean, how do we maintain our microbiome as we get older? And is it that we can maintain our microbiome, or which is cause and effect? Is it because we're aging and our body is producing more metabolites that it is changing the environment that will hold a healthy microbiome that will allow us to be youthful? Which is cause and which is effect? What's the feedback loop? There are a lot of questions here, but
one thing is clear.
It's young poo will keep you young.
Well, but this affected, I mean, they were able to show, like, we've done it with, like, skinny mouse, obese mouse, knockout gene stuff going on there. This one is demonstrating that if you have somebody who is having elder onset mental health issues, perhaps, brain health issues.
Yeah.
People think it's a gut transplant, it's for the gut. It'll make your gut. No. It's actually might be able to affect a whole range of other possible.
There's the whole gut-brain axis, right? And we are learning more and more about the connections between the microbes and the metabolites and the ways that the bacteria in the gut affect what's going on in the brain and how the brain affects what's going on in the gut. And there's all sorts of neat stuff there. Yeah, very interesting. Keep your gut forever young. I'm just going to sing songs from the 80s this episode. And I've got a story about freeloading cats. And it's a pretty quick story because, everybody thinks of cats as freeloaders, right? Mm-hmm. It's like, oh, you've got a cat. They're not going to work for anything. They're using you, right? I mean, that's not exactly true. There are relationships that we have with our cats. And, Justin may scoff at some of these ideas, but
I've had cats as pets. I'm not like they were my friends. So I get
could be
it.
your friends.
I'm not totally.
A lot of animals that have been studied with respect to the amount of work that an animal is willing to put in to get their food, many animals would actually rather work for their food than just be fed. It's it's good for their brains and all that, but lots of animals, giraffes, wolves, all sorts of animals, birds, rodents, like to work for their food. It's just what they enjoy doing. So these researchers from UC Davis studied a bunch of cats and gave them little cat toys, food mazes, and various things to see whether the cats would be more or less likely to work for their food. And not that they wouldn't work at all for the food. And then, like, some of them would go play with the cat food mazes to get their food. But more often than not, the cats just want to eat. And they don't want to work for it. Who knew?
Well, may I animal
Confirmation.
explain this for a second?
Please, animal splain, Blair.
So predators, they work really hard to take down a kill, but then they eat as much as they can. Like they will like fully gorge themselves and then not hunt again for, depending on the animal and the take, days, weeks. So that's one lifestyle. Then you have foragers and grazers, things like giraffes, and you have scavengers, which are kind of, wolves essentially. And so those animals are spending all day, every day looking for food. And so I think that has something to do with this. It's not just cats. I would guess that my experience with big cats, for example, is pretty similar. So I definitely think that part of it is just their adaptation to how they eat. And so if you're used to spending all day, every day foraging, and I give you a bowl of kibble, then you're bored. But if you're used to eating and then sleeping for 4 days, you're fine with that. That's
Bowl
totally
food,
cool.
great. I'm going to go lie down now.
Yeah.
And I think there's a slight misnomer. Like for a domestic house cat, there's no work around the house that a cat does. But for the most part, dogs aren't really doing any work for anything either. But if you got cats out on a farm, they're working. They're out there catching rats. They're keeping pests away. They're knocking down vermin. They might even.
But they're not often eating them.
No, they're killing them. But that's their job. Right.
But that's what I'm saying. It's a separate. That's fun versus food.
That's different parts of the process. I think that's the whole that's the whole thing
minds.
that Blair's
I
bringing
get
up.
that.
There's the getting, the acquisition, there's the eating, and then there's the postprandial nap.
Yes.
But we've taken something that is for outdoor vermin control. It's probably why humans. There's toxogandii in ancient Egypt mummies. Like we've been around cats for a really long time. But this is probably to keep, they probably had most of their cats hanging out around the grain stores or something. They probably had
waiting for the mice.
Work doing that kind of work. Brought them indoors where we've got it sealed off so there's no rodent. There's nothing for them to do. What are they? They're waiting for the job.
That's why you're supposed to play with your pets for a nice chunk of time, maybe a couple of times a day, and then they won't go outside and eat the birds.
Get them a catio.
Same
Get 'em a
study.
catio.
Train them.
Yeah.
These are things you can do.
Let a live mouse loose.
See what happens.
Experiment. See what happens. See if they don't go to work like that.
No, I have a
what their
feeling
job
my
is.
cats would not go to work very quickly at all.
Oh, maybe.
This is This Week in Science. Welcome. Thank you for being here. We're so glad to have you here joining us for another episode of Science Fun. We were just talking about cats, but how about a little COVID?
Oh, boy.
I don't have a lot of COVID, just a little COVID. All right, so a study has come out assessing the long-term effects of COVID-19, and there are over 50 long-term effects of the disease, ranging from hearing effects on your hearing, fatigue, headache, attention disorder, hair loss, dyspnea, which is difficulty breathing, loss of taste, loss of smell, coughing, sweating, all sorts of 55 potential long-term symptoms. The big take related to this, though, that is, I think, the most interesting aspect of this, 80% of symptomatic cases result in at least one long-term symptom. 80% of cases. That's a lot. So,
You know what doesn't have 50 long-term effects?
getting vaccinated,
Yeah.
wearing a mask.
Yeah. Everyone's talking about we don't know the long-term effects of the vaccine. We do know the long-term effects of COVID, and it's bad.
Yes, the long-term effects of COVID are not great at all. So just playing games with what's worse. I'm not going to play games with it. Long-term effects are not something to think about. And as we're thinking about long-term effects, one of the groups of people that has been brought up a lot more in conversation recently, as once again, school is returning to session in many places around the country. It already has. And classrooms have been shut down and classes have been sent home to isolate and quarantine because of COVID outbreaks in classrooms at this point. There is a concern about long COVID in children because the Delta variant is more transmissible, and being more transmissible, we are seeing more children in the hospital with symptoms. One thing that can be done is ventilation in classrooms. Kids who cannot be vaccinated, and actually any room, that indoor space where people are congregating, ventilation can play a major role in clearing out the viral particles, clearing out those aerosols that we release when we breathe, speak, sing. There's yet another study that came out this week confirming that fine aerosols are generated during talking and singing. So if you're talking and singing in the classroom, consider that children, you as a teacher, may be releasing these fine COVID particles, SARS-CoV-2 viral particles, into the air. What happens to those particles, though, once they are in the air is a big question. And that's where a study out of MIT has looked at ventilation in classrooms and provides suggestions for keeping classroom air fresh. Now, you can have heating, ventilation, air conditioning systems, HVAC systems that are huge, that maybe have filters that are able to manage the airflow. But ideally, windows and doors can be open and ventilation can be increased. In classrooms, kids wearing masks are mostly going to be breathing out, and the viral spread is not going to be horizontal because the masks will block the horizontal spread from their face. Instead, the spread will be vertical in nature. So kids are going to be breathing in the masks, and the airflow will be vertical, which is going to lend itself to vertical movement of the air up to the ceiling, where if you have filters and fans and all the stuff sucking into the air system, that's great. That air can be taken out of the room, and that will minimize the amount of viral transfer from student to student. These windows, though, can be a problem in cold weather, and they tested a system where they had cold windows, and they found that the warm bodies in the classroom and the warm air tends to rise, and all the ventilation goes up, but then the cool air along the windows will drop it back down again. And so students that are seated next to windows,
that was me daydreaming, looking out the window,
may be more prone to infection to COVID because of the way that the air moves in the classrooms. Now, they say that if windows introduce baffles that can direct the air more directly down to feet, then air can come in from outside, and that the whole air system circulation can be shifted and can address some of these problems. But in all of this, each classroom is going to be different. We need to do what we can to improve ventilation, knowing that in the winter there will be issues with cold air outside, warm air inside, and lots of little warm bodies doing a lot of breathing and talking and maybe even singing as they are preparing for those winter plays. Yeah. There are a lot of considerations, and I think it's very important that our indoor ecosystems are starting to address all of these, because COVID isn't the only airborne virus.
Mm-hmm.
It isn't. There are a lot of these things, and if we can clean it up for COVID, it's going to clean it up generally. A lot of these practices can help maintain health and sanitation for looking into the future.
I mean, we're talking about a future school.
Future school that
Not
has
one that
windows
exists now.
and HEPA filters and HVACs.
Yeah, no, really. You got to build it like a lab.
Well, and what happens when it gets cold and then you don't want to have the windows and the doors open?
Right.
Then everybody stops saying any words with the letter P.
Right.
To make a couple of adjustments. Atric? Is Atric here? Atrickson?
Well, yes, but anyway, this is an article. It is published by MIT in the journal Building Environment, but we will be linking to the PhysOrg press release on our website. So if there are any teachers who are interested in sharing this with their schools, or people who are looking at going into indoor work environments and want to share this information with their building managers, I think that this is the kind of consideration that science, looking at how things works experimentally and kind of checking our assumptions about how things work, can help us adapt and create better environments for everybody. Moving forward. That's it for the COVID update for this week. I don't want to talk about all the bad, scary stuff, so I'm solutions focused today, everyone. This is This Week in Science. Thank you for listening. Thank you for watching, if you're watching right now online. And if you enjoy the show, please consider heading over to twis.org and clicking on our Patreon donation button. The Patreon button will take you over to our Patreon community at patreon.com/thisweekinscience. And at that location, you can choose your level of support, anywhere from $1 a month to $1,000 a month. We like to dream big. Whatever amount you choose, it's going to help us continue to bring you science every single week in our conversational and friendly format. We want to continue to do this, and we want to bring it to you. We hope that you will help support us in this endeavor in bringing science and curiosity to more people. $10 and up, and we'll thank you by name at the end of the show. Thank you for your support. We really can't do this without you. And now we're gonna come on back to that wonderful time of the show that we like to call Blair's Animal Corner.
With Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
I have a story about bats and how they make choices. Now, I first, let me paint you a picture. You go to the movies. Remember that? You go to the movies. You say, I'm going to get a small popcorn. And then you walk up, and there's a small popcorn that's $3, a medium popcorn that's $4.50, and a quadruple extra large that's $5. What would you get? You told yourself you were going to get the small.
The extra large one. It's such a better deal. I'm getting so much, but I didn't know that until I saw how small the small was in comparison to the price of the big one.
I'm getting the red vines because I changed my mind entirely.
Now, Kiki doesn't want to play the game, but
I got primed by
Now,
how
instead-
little difference there was dollars compared to volume of the container.
Yes. So instead, if there was a small that was $3 or the quadruple extra large that was $5, and you told yourself you were going to get the small, you went up, and those are the two options. Which would you get?
Oh, in that case, that's a lot more money. Or
You
just
get the small.
I'd still stick with the small. That's really all I need.
This is an actual thing. This is called a decoy. The medium is a decoy choice, and it pushes you towards the more expensive, largest option because it suddenly appears to be a bargain. And this apparently is how coffees are priced, popcorns, travel decisions, even voting options. This kind of false or decoy middle choice is what pushes people to the extreme.
Yeah, this is exactly the playbook of a major appliance retailer that I worked for many years, where we would put those three next to each other,
Yeah.
the good, better, best, and good, better, best, without the one in the middle, you're right, doesn't work.
No.
You gotta have the little stair steps up too. In some cases, the entire appliance, like if you went into the washer dryer, the entire appliances were laid out from good, better, 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 better. Like everything kind of went up a little bit all the way down the line to the most expensive one, so that you could sort of just slide up to a higher priced but more featured product.
Right. So this decoy shifts attention away from the initial decision. And so this is something that's obviously been well documented in advertising, I guess, in humans. But it's something that Claire Hemingway, who recently received her doctorate from the University of Texas, wanted to look at in bats. Now, there are frog-eating bats. They're very rational about their diet choices. And then there are some fruit-eating bats that live in the same area that actually have less preference for their food. So frog-eating bats, very opinionated about their food choice. These fruit-eating bats, they'll eat kind of whatever. So with the Jamaican fruit bat, Artibius jamaicensis, they'll eat any sorts of fruit. They'll eat figs, they'll eat bananas, they'll eat anything. And they're really important seed spreaders. So because they can eat kind of a little bit of everything, they have this really important job of spreading seeds through their poop all over the forest. They also don't like to dine alone. So for this experiment, she had to catch a bunch of bats in mist nets in the forest and then set up dinner parties of 3 or 4 bats at a time.
Oh, I love this.
Yes. Then one by one, so they wouldn't be influenced by each other, she'd pull one out, presented them with food choices, and recorded their choices. She named the bats. Are you ready? Arturo, Aria, Bianca, Barnaby, Calvin, Cruz, Eliza, Fiona, Fernando, Gabriel, Grove, Heidi, Huxley, Ivan, and Isabella. They were named alphabetically by cohort. Love it. When they were given 2 choices, ripe bananas and ripe papaya, no preference. When they gave them a 3rd choice, unripe banana, they almost always chose the ripe banana.
I would too. Who wants an unripe banana?
Yeah, but why are you ignoring that papaya? That's the problem. So the presence of the decoy, the unripe bananas, shifted their focus and changed their behavior. Meanwhile, the frog-eating bats, Trachops cirrhosis, evaluated each of the food options she offered them, but they were not influenced by dietary decoys. They made rational decisions about what to eat. If they chose A over B and B over C, they would also choose A over C. So they really followed a strong preference. And so their choices did not change depending on which options were offered around each other. So that means, first of all, that some bats are fooled by this decoy and some are not. And that also means that they have factors like their diet or how they acquire their food that might produce rational or irrational behaviors. So predators, like a frog-eating bat, they go after prey that they actually have to hunt. They might have evolved different decision-making strategies than animals that just go up and eat any fruit that's lying around. So that could kind of push them to have different opinions about types of food. Her next step for her postdoctoral fellowship is to ask the same questions with bumblebees. They want to find out what drives bumblebee behavior and see if the same decoy mistake exists in bee reasoning. This kind of study helps appreciate animal abilities, of course. It allows us to tease apart the factors that go into human decision-making as well. So if this is something that we do and these other animals do, we can start to kind of draw logical lines into why it happens. How do we choose between resources? How does our brain work when that's happening? And then how does the way we perceive the world influence the choices we make? I also think it's really important to know this when you're looking at animal conservation. Because if something happens to an environment that adds a new choice or wipes out a choice, it's helpful to know how that's going to impact foraging strategies in animals. So I think there's a lot going on here. It's really interesting. I also think it's so funny. I've definitely fallen prey to the decoy trap many times.
So I think that's the interesting aspect, is that we share this cognitive, I guess, this trick. It's not a trick. I mean, we can be tricked by it. Yeah. This maladaptation, is it? How does it help us? Why is it something that we share with bats? Why do they have the same effect? And if invertebrates like a bumblebee, a honeybee, have the same effect, why is it so widespread between completely distantly related taxa? So that will be really interesting to discover.
I would think that it comes from a survival instinct, a necessity within all creatures, all living things, to take advantage of opportunity. That is like the simplest form. You have an opportunity, and you then maybe see this slightly better, easier opportunity. It's also that okay, that's the better opportunity. I'm going after that. And then you're getting there, and then there's an even better opportunity, right? And so you go after that opportunity. But whatever it is, that chain of chasing, like if we instinctually took the worst option every time, or the, passed by opportunities, probably wouldn't be here. No life form would. All life is on some
take what
level,
you have, as opposed to
take what you can get. Yeah, go take the better option.
But in this, I think in this case, papaya is not better than banana, or vice versa. And I think that's what makes it so interesting. Is you could say that, like in the human choice, you're trying to get value, right?
Yes.
But the papaya and the banana were both equally ripe.
Sure. But it triggered better opportunity because it had the comparison of the two bananas.
You're comparing the not ripe banana with the ripe banana. Yeah.
So it's triggering
suddenly
opportunity.
That's the best.
And that's the the ape, not even the ape brain. I don't know how far back we have to go. Maybe it's
we're
the
about
algae
to find
brain.
out. Yeah, if it's the bumblebee brain.
It's like all the way back.
Sponge brain.
Yeah.
How far does it go?
Like, take the better option. Over here,
slime mold.
You don't even know. There's only what was it? A mango? There's only one mango. Is it the good one?
Mold.
Is it a bad one? I don't even know. There's not another mango by which to compare this mango-ness. But I know the better banana, and I'm going to have the best banana.
See, the slime mold would just split into multiple pieces and take it all. So
yep. I will take all the opportunity I can.
Yeah. But speaking of sponges, what about sponges inside your body to protect from poison?
Isn't that a birth control method?
Not anymore.
Okay.
University of California, San Francisco, Stanford University, and the California Academy of Sciences, so a trio of universities in my neighborhood, have uncovered new clues. So not the whole answer, but just some clues as to how poisonous frogs and birds don't kill themselves. Your body's
This
full of
is an
poison.
amazing question. They're poisonous.
Uh-huh.
Yes.
How
yes.
do you
Do
not
they
kill
know
yourself?
how do you you preen and you clean your feathers or you lick yourself? I mean, I've seen frogs lick their eyeballs all the time. How do they not kill themselves by doing these things?
Yeah, so for example, the golden poison frog, truly beautiful, you should Google it, Phyllobates terribilis, is estimated to carry 1 milligram of the sodium channel blocker,
Those are cute frogs.
batrachotoxin in its skin glands. So 1 milligram of that toxin is enough to kill between 10 and 20 humans.
Wait,
How do they
what?
fill their
What?
body with that?
What is that? Wait, hold on.
Yes.
I just stop. What is that ratio? 1 milligram?
One frog, 10 to 20 humans.
Oh my goodness. That cute, tiny little adorable.
He's like
looks
this
like it
big,
would-
too. You
Yeah,
have
it
to
would
understand,
fit.
he's like the size
That
of
is
a
death
finger.
in a little
Finger.
tiny package.
Oh.
Yes.
And I can
And-
kill 20 people with this?
Yes, and I will also mention if you ever see one of these guys in a zoo or in an aquarium or a science museum, they themselves are not poisonous in that museum or zoo or aquarium because they obtain the toxin from the insects they eat. So because they're being fed little feeder crickets and things like that, they do not contain the toxin. And so they build up the toxin in their body from the insects and store it for long periods. This is why it's even more confusing that they don't kill themselves with it. It's not like they are producing the toxin. They are ingesting it and somehow not dying from it but maintaining it so that if some other animal tries to eat it, that animal will die. So how are they not getting paralyzed? So these toxins cause paralysis and cardiac arrest by binding to voltage-gated sodium channels. And so that is what mediates electrical impulses in neurons, muscles, and the heart. So it just shuts down your neurons, essentially. Not good.
Yep, you're not gonna send any more electrical signals, and your heart stops, and death.
Very, very much death. And so it was for a long time assumed, with a hope that someday there would be scientific proof, that these animals evolved batrachotoxin-resistant sodium channels. But there have not yet to date been any functional studies of poison frogs or the poisonous birds with sodium channels. With even studying their sodium channels themselves. So whether they can rely on changes in their channels or they have alternate resistance mechanisms, unclear. They have yet been unable to study these sodium channels. So in this new study, they set out to do just that. They wanted to see what was happening in the sodium channels when exposed to this batrachotoxin. They compared the effects of batrachotoxin with saxitoxin, a well-known paralytic shellfish toxin, and it suggests that these poisonous bird and frog species, they don't have functional resistance in these sodium channels. It looks like they actually have a way of holding these toxins in reserve to prevent them from going anywhere near the sodium channels. The frog sodium channels were sensitive to batrachotoxin levels more than 10 times below what is currently present in those teeny tiny frogs. So 1/10 of the amount they're carrying in their body was shown in the lab to shut down their sodium channels. So that means there's something else going on. And so this observation challenges the idea that there's some sort of mutation in the sodium channel to resist the effect of the toxins. So this new proposal is that it's all about sponges. They have an alternative auto-resistance mechanism, aka a sponge. Basically, it's a sponge protein that they say mops up, but really kind of absorbs and holds the toxins to stop them from binding to the sodium channels. So although this batrachotoxin binds to the isolated frog sodium channels, if they inject it into a living poison frog, no effect. So they don't... This is the leap of faith, though. They don't yet have any proteins isolated or identified that would be capable of this. But there is something analogous in bullfrogs. Bullfrogs produce a protein that can bind to related poisons. So they've seen something kind of similar in bullfrogs, not at the same level of poison, not the exact same type, but similar-ish structure. So they think it's a possibility. And, you know, frogs, since it is another frog, there could be a kind of an evolutionary origin to this potentially. And so essentially they've kind of disproved this earlier assumption that there was this mutation, and now they are moving in this direction of finding out where's it hiding, where's it being stored, how's it being stored, how is it being prevented from going at the sodium channels.
That's so fascinating.
How do you get it out again? It's on the skin? Like, where is the toxin? Like, how do you interact with it? How does it zap stuff?
How does it zap stuff? You eat it.
Oh,
Yes.
so it's just...
Yeah.
It's in the tissues of the frog.
Yeah.
Okay.
It's in it, yeah. That's like the whole urban myth about licking toads. That's where this comes from. You're basically dosing yourself with toxins. So
yeah, but I mean,
yeah.
like,
But on
Processed
some
food.
frogs, they're excreting a toxin that can be hallucinogenic or psychoactive. This frog is just
Poison.
these frogs are poison. Yes,
yes, it's
completely poison.
extremely strong.
what was
yes,
the
and so-
what was the scientific name again? Something terribilis? Or...
Terribilis, yeah.
Yeah.
And that is why.
that
Yes.
right
So
in the name.
Terrible yellow
helpful
frog.
to know. We've never really known how this all works. Of course, if scientists can figure out exactly how they are storing and preventing the activation of the toxin going at these sodium ion channels, that could potentially lead to new discoveries of antidotes against various toxic agents, because anything that attacks these sodium ion channels, which is a lot of things that we have to worry about as living things, this could help potentially with treatment for that and prevention.
I wish that they actually had found a molecule, or that they had some kind of sponge target. I mean, it is, like you said, a leap of faith in the logic. It's like, well, we don't have this, and we have this, we don't have this, and they've put it together, and it's like, well, there's got to be something in there doing something, but they just don't know what it is. Maybe it's a sponge, but maybe it grabs onto whatever, the batrachotoxin, but maybe there's something else going on.
Who knows? If we
still
find
don't know.
out, I will report on this show.
Very interesting. Thank you very much.
Yeah.
Thank you very much. And thank you, all of you, for listening to This Week in Science. Have you checked out our Zazzle store lately? Over there, we have some great t-shirts and lumbar pillows, throw pillows for your couch. We have beach towels, TWIS beach towels. There's some really cool stuff. Click the Zazzle link at twis.org and shop to your heart's content and support TWIS while you do it. Hey, Justin, do you have any stories?
Yeah. So, The Matrix. Do you remember the plot of The Matrix?
It's one of my favorite movies.
Okay. So you know what the aliens or whatever, the agents, you know what, when Neo comes
They're
out
robots.
of the goo?
Yes.
Well, when Neo comes out of the goo, he was plugged in and he gets unplugged.
Yeah.
And then there's tens of thousands of millions of humans in these little pods.
Yeah.
Why are they there?
Batteries.
Exactly. Ridiculous. Humans are terrible batteries. We're
We're so
wasters.
energy inefficient. Yes.
Yes. So this was changed by the production company. The original pitch and story was that they were part of a neural network, and that the aliens or whatever were harvesting human brain computing power. Isn't that a better story?
That makes a lot more sense, actually.
But that,
Okay.
I mean, I don't exactly remember, but I think when The Matrix came out, it might have been also when AOL was debuting. Like, it might have been like, you know, internet, it's not, people won't understand what you're talking about. Well, interconnect brain. Anyway, they're doing it. Oh, so this is a new study showing that artificial intelligence networks based on human brain connectivity can perform cognitive tasks more efficiently. They basically did a bunch of examining of MRI data from a large open science repository. Researchers reconstructed a brain connectivity pattern. Then they applied it to two artificial neural networks known as M.A.N.I.A.C. An M.A.N.I.A.C. is a computing system that's, it's got the inputs, the outputs, that sort of thing, like a biological brain. The team of researchers from the Montreal Neurological Institute Hospital and the Quebec Artificial Intelligence Institute trained the M.A.N.I.A.C. to perform cognitive memory tasks and observed how it worked to complete assignments. They found that ants with human brain connectivity models, known as neuromorphic neural networks, performed cognitive memory tasks more flexibly and efficiently than other benchmark architectures. The neuromorphic neural networks were able to use the same underlying architecture to support a wide range of learning capacities across multiple contexts. And so this is one of those things that whenever we've talked about deep learning or these new AIs, the machine learning systems, they're still 100% based on the input that humans have given to them. In terms of learning, they're not great. In terms of sorting massive amounts of data, they're fantastic. But in terms of adding anything substantive that hasn't been given to it, they're not that great. They're not great at reaching in.
But they're learning.
But are they? Are they just filtering? This is a system that's using human brain architecture to actually do some learning. Anyway, I thought it was fascinating.
And I think that I like the influence here on this study using structure leading to function, and that has been like that's one of the statements in biology, right? It's structure leads to function. Function will help us understand why the architecture, the structure is the way that it is. And so by modeling our neural networks on brain architecture, this makes this structure begat function kind of systemically work. And then from the other side of it, I've seen some other news that these neuromorphic neural networks that are also challenged by resource availability and by the networks that they're in, so that it's not just easy sailing all the time, that where there's actually some difficulties and there are some critical limits to how they function. Similar to the human brain, they function more like the human brain. So there are a lot of researchers who are kind of really taking the modeling of these neural networks from human brains very seriously. Will we make a mini-me? Maybe.
And then eventually the AI is going to be like, I need more computing power. I'm going to put all the humans into pods. And,
Thank you, humans.
And put them in a dreamland and harvest their brain computing power. Not battery power. Matrix, editing the writers, editing the creatives. Stop it. Just go with what you purchased the shit. Just let them do it. You handle the marketing and the money. Last story I've got tonight. Potential new treatment for mast cell tumors. Mast cell cancers. They found a way of reducing the number of mast cells by mutating messenger RNA before it delivers instructions for manufacturing the gene that is responsible for cell proliferation. Basically what they did is they kind of made like a fake mRNA that was just off by enough that it would still transcribe, still try to make the protein, but it wouldn't be quite the right configuration, and so wouldn't operate it wouldn't initiate more growth within the mast cells. This is still not a thing that they're going to probably put in humans anytime soon. But this is something that this is like the number one, I think, we're one of the highest killers of pets. Like if you have an old dog or an old cat, these mast cell tumors start showing up at some point.
Oh, really?
So I think it's
interesting.
I think it's one of those things that there's a model out there where we could put this in the hands of veterinarians in some way and let them test it on pets. Like, this is actually how we got hip replacements. We got hip replacements surgeries that are so amazing through Labrador retrievers, right? And black labs. They have just horrible hip problems earlier than most dogs, right? This is usually what takes them out before anything else. And so they started, the medical and research side started doing these free hip replacements on Labradors. Now, as a human, if your hips are going out and your hips are going bad, you can go and get double hip replacements with the titanium integratable thing where the bone mass will grow through it and the robot will do the chiseling and all that stuff will happen. And you'll be back walking again in a couple of weeks.
But great, that's awesome for the hip replacement. But for these mast cell tumors, this really worked in the mice. They were able to really reduce the size of the tumors. Were they able to
reduce
stop
size
them?
of tumors? They were cessation of growth. I mean, it was a pretty. It's what they're calling it is they're calling it frame shifting. By using this mRNA, going in there and basically attacking the mechanism that signals growth.
Mm-hmm. Right.
By
So there's a
getting
genetic
into that-
signal. There's a genetic signal in the tumor that's like grow, 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 blah blah blah, and then this mRNA comes in and goes, nope, you should
Looks
stop
like
that.
the thing. Looks like
It's a
the thing
control-
that's
it's a
supposed to
control
be
signal.
there.
Yeah.
Okay, right? But then is making like it almost reminds me a little bit of a gene drive to an extent, but it's not that. No, I shouldn't have said that. That's not what it is.
It's gene therapy
It's a
for
gene
sure.
therapy.
Yeah.
But it's fooling the mechanism into treating it like it's the real thing, and then it goes into action and it can't operate. And so there's no signal to grow. One of the things about cancers is that what they actually lack is being able to accept the signal to stop growing. They don't get the signal for apoptosis. They don't get that signal, which is sent by surrounding cells. Surrounding cells are actually doing the messaging like, hey, knock it off. But what they keep getting is the grow, grow, grow signals. Those ones still keep coming in. If you shut those down so they're not getting that signal to grow anymore, they stop spreading. They stop producing more of these mast cells. And mast cells are fine if you have them in the right numbers. That's not.
Yeah.
they're not-
So I think the question is, how do you get the gene in there? How do you do the gene splicing? You know, one thing in a rodent model, but how do you do this in people? If you're going to address it, can we use the maniacs? Mm-hmm. Can we use the magnetic maniacs?
That'd be great.
Yeah, to send those in there. Yeah. How do you actually target those tumors and then and do the gene therapy that needs to be done? So those are the actual.
So the thing is, I don't know that you couldn't do along the lines of the mRNA vaccines that we've all had shot
Could
into
that
our
work?
arm. Because if you've been off to the pathologist who has said, okay, here's the proliferating cell type that is causing this issue, and you have done the research, or someone has done the research that tells you how that is signaled, how that proliferation of that type of cell is signaled. Then you can actually just sort of insert for some period of time the messenger that is blocking the signal. The messenger that doesn't have the right information when it gets to,
Yep.
like a messenger has arrived. Oh, I wonder if he has a message.
Stop
I
growing.
don't. I forgot. Oh, they said some stuff and it sounded important, but that was a long trip, A lot of stuff happened. It was actually, I kind of grew as a human being along the way, but I can't remember what it was. Like that's basically the...
Yeah. I don't know. Stuff like mRNA stuff is going to... It's going to explode. We are going to see so many therapies, vaccines. It's exciting. Yeah. Using mRNA to target various things. That's going to be interesting to watch that develop. All right, I've got a couple of stories for the end of our show. You want to talk about something?
Yeah,
Like-
what though?
Oh,
Right, but if
we talking
if we
about
would-
that?
Yeah, if we're doing this podcast together and we're talking together, it's like I'm like, hey, let's talk about this. And then you guys are like, okay, let's talk about this, And then at the end of the show, and our listeners are like, okay, I want to listen to this. Great. We're all doing this communication thing together. And then at a certain point, I'm like, hey, did we finish the show? And you guys are like, yep, we did it. We did all that stuff. And then listeners are like, okay, it's the end of the show and we know what's going on. We communicate this whole process of starting some joint process together, and then we communicate the end of that. We enter into an agreement and we exit through an agreement that it's done. And it turns out that apes, surprise, surprise, bonobos and chimpanzees, just like humans, start and end their social interactions. Very similar ways. A study published in the journal iScience, researchers documented apes using signals to start and end their interactions. They're not just random interactions. The apes don't just go grooming each other willy-nilly without cooperation. This is something that is entered into as an agreement. Adults don't play with the kids just whenever they want to. No, the kids and the adults got to work on that together. So these researchers, led by Rafaela Hassine, postdoctoral researcher at Durham University in the United Kingdom, she says that this ability to be able to achieve things that are bigger than can be achieved by a single individual alone is suggested to be at the heart of human nature. And part of this, sharing the intentions and working together, joint commitment to things, is something that has been thought to be just a human trait. Nope, not just a human trait. It goes up our family tree quite a ways.
Yeah,
And,
when is it ever, really?
So,
Right.
that's a pretty handy thing, though, isn't it? Letting somebody know, all right, well, I'll be seeing you. Like, I'm done talking. Let's move on to other things now.
Yeah,
You know what
and
this
so-
made me
Very
think of was walking the dog, right? And two dogs come up to each other and they start sniffing each other's butts and they're circling around, and it never feels totally in sync when they're done to me. I always feel like one
Right.
dog is done sooner and they're like, all right, let's go. And the other dog's still smelling their butt and they're like, okay, but let's go. So one dog decides they're done before the other. It's not often a mutual decision, I feel like.
It's not completely a mutual decision, but there is part of it in when they do actually go past just that greeting of moving on to play, like you're at the dog park and the dogs decide they're going to run together or they're going to all do something together. But then at some point your dog decides they're done and your dog is just going to come back to you.
Right.
And that is something that is the other dogs realize your dog is no longer playing with them. They have made behavioral that probably these dogs, I don't know about this being tested in dogs, it probably should be,
Yeah.
but in chimpanzees and more specifically bonobos, actually, these kinds of intention to begin and intention to exit behaviors were very apparent in these different species. Yeah. What they did find with it was that was very interesting. They looked at 1,242 interactions between bonobos and chimpanzees in zoos. They found that apes did gaze and communicate with each other to start and end these interactions. Bonobos exchanged entry and mutual gaze prior to playing 90% of the time. Chimps, 69% of the time. Exit phases were more common with 92% of the bonobos and 86% of chimpanzees involving these exits. So there are a number of different behaviors that are involved, but it's very interesting as well considering the different the social differences between bonobos and chimpanzees, that they had these differences in the percentage of initiating and exiting, and that the initiation was more often bonobo mutual, but less often the chimpanzee being mutual. But chimpanzees were better at mutually going, okay, we're both done now. I don't know, just very interesting considering the different level, their hierarchies and how they work together. But, yeah.
Hey, Blair, you worked at a zoo.
I did.
How often do you catch the animals communicating with each other?
Oh, constantly. I mean, if they're in exhibits together.
Well, no, I mean, like
the giraffes talking to the
I
dolphins.
don't know what the giraffes talk about. I feel like the lions never look at each other, but that's probably not.
Oh, they certainly do. Yeah.
They want to eat you.
Well, and you also have to remember that in terms of verbal communication, our ears are terrible. So I remember really early in my intern days, we had a story about how giraffes have like they have a whole language, and we've never heard it, so we've never really thought about it. But yeah, there's a huge amount of verbal communication happening, but the body language is intense. So one of my favorites is that bearded dragons, little lizards, will wave at each other. And that's not a friendly wave. It's actually hey, this is my space. Do you see me? Space. This is my space. This is this dragon's space. Stay away. So.
But what would that bearded dragon do with a hammer if it was given a hammer?
Purely nothing.
Right, nothing. And an orangutan? What would an orangutan do?
Something.
Right, but how would that orangutan know to do something with that hammer?
Observation.
Would it have learned it from another orangutan? Or would it just play with the hammer itself?
Yeah, I guess it depends. It depends if they've seen another orangutan use it, and or what age they were when they saw it, and or what their relationship to the other one was.
Yeah, so another study out this week, very interesting, primate behavior. Orangutans don't need to have observed other orangutans using a hammer to use a hammer. And this is a question that the researchers thought interesting because of, the question they thought was interesting was that whether this kind of behavior has to be learned or whether it would continue within the apes if, say, there were some kind of population trouble. Maybe populations were split up and one group didn't have the hammer behavior and another did. Would the hammer behavior ever arise again? And this study suggests that there is a curiosity and playfulness, but also tool use just generally, inherently in young animals. In their study of a small group of orangutans at German zoos, they saw that some larger, older orangutans didn't even bother with the hammer. They just cracked the nuts themselves. But the younger orangutans were more likely to pick up the hammer and use it to crack nuts. So could also be a youth versus age curiosity
Early
and
handheld devices.
Yeah.
You know, it's always the kids that pick it up first.
yeah, so the kids could pick it up. But not everybody, like, you know, the orangutans maybe didn't have to pick stuff up, but apparently mice, little female mice, need to learn how to be a mom from other moms. That the behavior of taking and protecting little young pups, that virgin mice, never having had a brood of pups of their own, just upon observing another mom take her babies from an unprotected place and to herd them back into their little nest, that observing that behavior, it is picked up by the younger mouse, by the inexperienced mouse, and that mouse will then go on to perform that behavior even without getting pups of her own yet. That she would go and start herding other mom's babies back to safety if the mother is nowhere in around. And they found that this is all mediated by oxytocin. So these researchers at NYU Grossman School of Medicine published this study in Nature this week, what they call a never-before-seen behavior, where mouse mothers shepherd these new mouse mothers would, without prompting, shepherd virgin female mice into the family's nest along with their pups. The virgins began mimicking the maternal behavior of gathering the mom's pups into the nest. And if these virgin mice only viewed this through a window, they would start doing the behavior. If they blocked oxytocin, the behavior was not picked up. And so it's one of the ways that we know that oxytocin is not just a hormone for love and bonding, but also behaviors that are related to parental care. And that to be a good mom, at least for a mouse, oxytocin needs to be present, but also the occasion to learn from another mom. Which is pretty fun. Yeah.
That's awesome.
You will teach the children well. Shepherd the babies into the nest. And the babies will learn to shepherd other babies into the nest.
There's a video that we put up that is a mouse straying from the little detritus pile. And the big mouse coming and saying, this way, come on home.
What are you doing out here? Get back in there. This is, yes.
Oh my gosh. Like pulling by the tail, like, hey, hey, get back inside.
Get back inside. What are you doing out there? You're going to get run over. Don't ride your bike in the street today. Momminess. Oxytocin, it's important for parenting. Complex social networking activities. It's very important. Have we done it? Did we make it to the end of the show?
We have
We
done it.
might have. Is it really that time?
It is. I think we have. Then we've made it to that time when we're all done with all the stories, and it's just time to say thank you. Thank you for joining us for another episode. We do hope that you enjoyed it. And I want to say thank you to a few people who help out the show. Thank you, Fada, for all your help with show notes and show descriptions. And thank you to Gord and all the other moderators who are out there helping moderate various places. Thank you, Identity4, for recording the show. And thank you, Rachel, for your assistance and editing. Also, thank you to our Patreon sponsors for all of their support of the show. Dun, dun, dun. I can never get this up when I need to. Thank you to Pierre Velazar, Ralphie Figueroa, John Ratnaswamy, Carl Kornfeld, Melanie Stegman, DeKramsta, Karen Tazi, Woody M.S., Andre Bissett, Chris Wozniak, Dave Bunn, Vigard Shefstad, Hal Snyder, Jonathan Stiles, a.k.a. Don Stylo, John Lee, Ali Coffin, Maddie Perrin, Gaurav Sharma, Shub Brood, Don Mundus, Stephen Albaran, Daryl Myshak, Stu Pollock, Andrew Swanson, Fredus 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, Matt Bass, Joshua Fury, Sean and Nina Lamb, John McKee, Greg Riley, Mark Hessenflow, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, Johnny Gridley, Kevin Railsback, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Hey Arizona, support Aaron Lieberman for governor, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Mallory Sutter, Philip Shane, Kurt Larson, Craig Landon, Mountain Sloth, Jim Drapeau, Sarah Chavez, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, Tony Steele, Ulysses Adkins, Brian Condren, and Jason Roberts. Thank you for all of your support on Patreon. And if you would like to support us on Patreon, you can find information at twis.org. On next week's show,
We will be back broadcasting Wednesday, 8 p.m. Pacific Time, live from our YouTube and Facebook channels, as well as from twis.org/live.
Hey, do you want to listen to us as a podcast? Just get our voices in your ear holes. Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, you should get your friends to subscribe as well. Get us in their ear holes.
For more information on anything you've gotten in your ear hole here today, show notes and links to stories will be available on our website, www.twis.org, and you can also sign up for our newsletter.
You can also contact us directly. Email Kirsten at kirsten@thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twis.org. Just be sure to put TWIS, TWIS, in that subject line, or your email will be shepherded into a hole that is really just a garbage can by a matronly mouse.
You can also hit us up on the Twitter where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you learned anything from the show, remember,
It's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views. But I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. 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 And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought. And I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say. And if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
And that is the end of the show. We are in the after show. Justin is somewhere. I do not know where. What's up, Blair?
Nothing.
Nothing.
Nothing at all.
Yeah. Oh, yeah. Thanks for all these great comments that I can show on the bottom of the screen. It's fun to be able to show what you say in the chats. I can share things. Maybe if I decide. I'm not going to share everything. Oh, you're sitting down now. I see.
Yes,
Yes.
the time has come for a nice sit.
Oh, Justin is fine. He is doing whatever he does at the end of every show. Runs off.
Ominous.
He'll be back again. He'll be back. But he said, what time did he say he woke up? 3:30?
Yeah.
Been up since 3:30?
Yeah, that's no good.
That is no good at all. It's early.
My
in
regular
the
wake up time is 5 now, so
5. I don't understand it. You've said that before.
Mm-hmm.
I know, and you have to go for the run, and you have to do the dog, and you have to do all the things. But why?
well, I also start work an hour earlier now.
Oh, that would do
So
it.
yeah, so and I have to drive to work now.
You have to drive.
Yeah.
Yeah.
I start an hour earlier and I have a 45-minute commute. So pushes things back considerably.
Ugh. Blech.
Yeah, well.
Blech. Blech to commuting.
Yeah.
Blech. Let's see. Is Kai's school reopening? Yes. Yes. Kai's school is reopening. Portland Public Schools is going full bore straight ahead with opening up full class sizes. I don't know what I'm going to do. I don't know what we're going to do yet. I don't know that I am convinced that it'll be safe enough with, 20 plus kids in a class, and I'm not convinced this is a good situation. So, but anyway, 3 p.m. in Australia. Ha! Nice work, Daniel Smith. Our in-law woke up at 5 in the evening. Oh, yes, Paul Disney. Yeah, this is something that we didn't talk about, but it is right now the Perseid meteor showers. So if you're up and the sun isn't up yet, Blair, perhaps if it's not foggy in the Bay Area.
It'll be
you can
foggy.
see- yeah. If you have clear skies, some meteor watching might be in order.
Yeah.
Absolutely.
Yeah, I don't think I've ever successfully seen it because of the fog.
That's one of the things, like here in Portland, maybe we have so much light pollution in town though, so you have to get up and leave town to be able to see anything.
I think Neil deGrasse Tyson said the first time he'd ever seen the stars was at the Exploratorium at the Natural History Museum in New York, where he is now the head of, right?
Yeah.
Because the light pollution just made it impossible, and probably a combination of that and weather. But
Can't look up at the sky. I mean, you look up and all you see are the tops of tall skyscrapers. Yeah.
all the tall buildings, so many of them. It's really impressive what they've done there, but they can't see the stars. Yeah, this is the time of year in my youth days, that I would go out with a bunch of friends, throw down some blankets, out in the middle of some farmer's field, and just watch the show.
Yeah, Davis is wonderful because it is so rural. It's grown a lot recently, but it's still in the middle.
Oh, you do not have to take, it's not
farms
far
and
to
fields.
go.
Yeah, you don't have to, you can ride your bike out to get away from the light to be able to see stuff if you want to. Yeah. Yeah, Davis is great for that. And in the Central Valley, you don't get those the cloud cover in the summertime that
No,
other
and
places
thankfully
do.
the
So
smoke
it's great.
is cleared.
Yes, for a minute.
This, by the way,
minute.
this ginormous fire is taking place in my childhood wilderness wonderland.
Oh no.
Where
It's everywhere.
I got to wander around in the woods and we were caretaking a ranch, 800-acre ranch out there, which is the other thing that nobody's talking about. It's like it's like a few thousand people have had to move. The town of Taylorsville was right near there. We were like half a day's horse ride from Taylorsville, which I'm not sure how far that is. It might be like 6 miles, something like that. This is how rural we were living. We had all these horses from the Bureau of Land Management, these wild Mustangs that they were going to cull in Nevada, and they were just giving them away. My uncle took like 7 of them. But there's cattle. That's cattle country up there. There's cattle all over the place. So we're talking about these people who got evacuated. I don't know where all these cows went. They could not have gotten away.
That's one of the huge issues. These massive wildfires. People don't talk about. You occasionally see, a picture of a stranded bear or deer or something that's a very stark reminder of it. But yeah, I mean, not just wildlife, but our ranching life.
But
Yeah.
thousands and thousands, probably, I don't know. I'd just be making up numbers, but there's definitely a magnitude more cattle than there are humans.
People, yeah, and people aren't really talking about that. And how do you get them out? For sure. I mean, the cows don't want to be near the fire, so they're probably moving themselves. But
although I hadn't looked at the region in decades. Turns out there was a town, Taylorsville, again, that was the half a day's ride, that had a population of 15. When I was like the mayor's wife was the sheriff, and they both worked at the post office, and they like it was and it had a general store, which they probably owned. It might have just been them living there, their family. But it has grown. It's 10 times bigger now than it was then.
so there's 150 people now.
50 people in Taylorsville. Then there were 30, 40 something years ago. Yeah. It's really blown up
Yeah.
in those years. It's in a very rural part of California, is the point. And it's a gorgeous, gorgeous area. And that was a place that at night, when you looked up at the stars there, forget going out into the farm fields outskirts of little town of Davis. You saw the wheel upon wheel of, you saw everything. I mean, that is the most incredible sky at night I have ever seen. I've never seen anything else that has ever come close to it, because there are no lights.
Yeah.
There are
the Rocky
there's
Mountains. The Rocky Mountains, Colorado. There's a lot of sky up there. It's a lot of sky. It's pretty amazing. Yeah, but we really do have to get away from people to be able to get a good view of space. And now we've got all the other stuff that we're putting up in space. Billboards. Have you heard about the little tiny billboard Elon Musk is launching up, like on a CubeSat?
Yo, do you remember that this was my CubeSat idea? This was my idea from I don't know how long ago that was. We were talking about what it would take for TWIS to launch a CubeSat. I was like, we need a camera that points at the thing that has a little scroll on it that you could have the planet Earth in the background. He's stealing my idea from 20 years ago that I never used. But still, came up with it first, Elon, just so you know.
Ah, you should have patented it.
I'm not going to patent it.
No.
Ideas should be shared. Just somebody can just go do it better. That's all you need to do.
Blair, you're frowning.
Yeah, she's reading. That's her reading face.
Yeah.
Frowny reading face.
Yeah. I have mine's worse.
Reading
Mine's
through the
really-
chat.
Mine's like this.
Everybody,
That's my reading
pretty
face.
reading faces.
I don't know what happens. But the whole lower jaw just goes slack. I'm like,
Yeah. Yep.
Oh my goodness. nature. Yeah, right now we've got super hot temperatures. We've got a heat wave going on, and luckily we don't have a lot of smoke here, but I know there is smoke and fire in other places. And the hospitals are filling up from COVID, Delta variant. So as we go into the hottest part of the season, we're going to be up against a lot of health issues related to heat and overheating. And things are going to be coming to a head here in the United States in just a
Daniel
little bit.
Smith in the chat room saying, never thought about the effect of the massive fires, floods on wildlife down here in Australia, though I know, paradoxically, the trees love fire down here. Yeah, actually, all you need to do is look at Tasmania. They have the same trees in Tasmania that they have in Australia, but they are some of the tallest trees in the world. And it's because it's a tree that never stops growing. Just in Australia proper, because it's just they burn every once in a while, and that's how they reproduce. They need a fire to reproduce. But down in Tasmania, the little tiny island south of Australia, those same trees are in a rainforest condition. They don't have fires. They haven't had a fire in 400 years. And those trees are 400 years tall. They're like, I don't know if they're taller than the tallest sequoia.
Those are some big old trees. Yeah.
Yeah, but similarly, like they're up there. They're like if they're not the tallest, they're second only to the sequoia.
Yeah, but not only, I mean, wildlife is one issue. A lot of animals die in fires, but then as you were bringing up the ranch wildlife, like I know people who own horses, and whenever they're down in the LA area and they're out in a rural area, but whenever there are fires down there, they're like, I have to evacuate my horses and my dogs and my birds and try to get everybody out.
If you have more than 1 or 2 trailers that you got, it's impossible.
Yeah.
Basically.
Yeah.
And then you're talking about, then fences are burning maybe, and then you've got wildlife out on, domestic wildlife out on roads and wandering off into the wood, like running from fires. Like it's just a horrific scene.
Are we in El Nino, La Nina? No, we're in a drought. We are always in, like, I guess the ebb or the flow. I don't think we are in an El Nino or La Nina year this year, but we're kind of in between them.
But there's some
we're in
evidence,
a drought.
I think, that isn't there that California was in a wet season when the Spanish first started exploring it?
Yeah.
It's like been a couple 100-year wet season, and it's actually normally more drought-like conditions anyways, which is just we're getting back there very quickly instead of over slow progressions of time.
Yeah, really fast.
But one of the things
fast.
that you can look at is native wildflowers in California are more fire resistant than flowers elsewhere. They they have tap roots that go deeper than non-California native fauna because they are flora because they're
they know they need to find the
deeper.
water.
They know to go deeper. They already know you're not going to get it on the surface, and they have better dormant periods for drought. Like poppies you can have a couple of seasons without rain. These poppy seeds are out there, just the California poppies dispersed out there. Finally, a few years later, you get rain, and they will just show up and like nothing ever happened. Like they didn't miss a season.
Yeah.
But they have to get rain at some point, which is where we're failing them currently.
Yeah, but it might not be out of their range yet. It's going to be the non-native plants that are really going to suffer, which is like everything that we grow on every farm everywhere, and everything that's in everybody's front lawn, and everything that's in everybody's garden.
Well,
There's
except
a lot
the-
of non-native.
The other piece, though, is that the non-natives burn harder and hotter, and so you might have fires that are surrounded by plants that burn hard and hot. Then it might not be so easy for them.
Yeah. The other thing is the native indigenous peoples of California did controlled burning. And it was a thing that once there was governance in California by the United States or the state of California, they started forcing them to stop doing it. Didn't ask why you're doing this. How is this a thing? Can we learn why the people who've been living here for, I don't know, maybe 20,000 years have controlled burns? What are you doing that for? What's that about? No, just stop. Just stop. That was, there's a knowledge
And now we have massive fires because we didn't manage everything appropriately.
There's a knowledge of biome ecology and conservation, or at least symbiosis, that you can get from an indigenous population that is something that, with all of our observations, with a few hundred years of looking at California, we're just starting to figure out why that's a good idea.
Oh, come on. Don't new immigrants to an area. You always know better. Come in and say, I know how to do it better.
Stop your immigrant bashing.
I'm a new American.
It's also frustrating because, if we hadn't pushed the native peoples out of natural lands, we wouldn't be spending all this time and money and resources to try to figure out how to manage it properly now ourselves.
Yeah. And by pushed, I mean, that's a very soft word. Let's use the
kicked, shoved, and stole. Is that
genocide.
appropriate?
Actually, genocide. Genocide is the actual appropriate word. Genocide is what took place.
Yeah. Yeah. And we are reaping a lot of the downsides of all of our past misbehaviors and crimes, and just misunderstandings and hubris and
chemical warfare when we gave people blankets laced with polio so that they would die. I mean, hubris. Oh gosh, no, it was genocide. It's just like, I wish people would just
I'm
stop
talking about
ever...
I'm talking about the hubris of thinking that coming
we
in
knew better. Yeah,
we knew better. We know how to manage this. We can take care of this land. It's fine.
I'm from Ireland.
What are you doing?
We don't burn anything in Ireland. Yeah, Ireland is a moist sponge of an island. You don't have. It's like, we don't do this.
We can grow
London. Yeah,
potatoes.
you're covered in fog all the time. You don't.
Potatoes. That's what I know how to.
Yeah.
Yes.
I'm from the Netherlands. Let me tell you, we've never had a forest fire. Yeah, you're half underwater. Stop it.
Wait, you're talking about all my peoples here.
Yeah, well, I have a lot of those peoples
I know how
as
to
well.
manage forests.
I have a lot of those peoples as well. But it's, whenever the invasive species shows up, it's like, I'll just put my seeds down everywhere, everything will be fine. And then you hit a drought and you're like, what is this? It's actually seasonal. It's called summer here.
It's seasonal, but IPCC report these kinds of things are going to get worse.
Now, the only thing I saw that was...
More and badder. Not gooder.
Only thing that I saw out of the IPCC that wasn't kind of like, it's kind of what we kind of just knew before. And it is a thing we knew before, but it's happening. They're seeing evidence of the slowing of the Atlantic conveyor belt.
Yeah. Yep.
But
they said it's not going to turn into the day after tomorrow. It's not going to turn into the disaster movie where they're like, things are going to change, but it's not that. It's going to be that. Not going to be that extreme.
You know, one of the fun things I listened. This was a guy who was out of Boulder, Colorado. I think he's out of the University of Copenhagen now.
Copenhagen.
Jason Box, who I still want to get on the show someday. He was explaining that one of the interesting things about sea level rise is that it won't happen to the Scandinavian countries and a lot of the northern Arctic countries, so probably also maybe not the southern as well. because there is so much weight in the ice that when it melts, the Earth will actually rise in elevation. It'll put it like, because it's got pressure on it. When that pressure is released, the Earth in a large part of the Arctic Circle will actually rise.
Yeah,
maybe not more than the water's coming, but it'll make it so that there's not significant change. What will change significantly, and even probably therefore more than the reported the sea level rise, because this whole effect is still not in the IPCC, is the equatorial regions will rise much faster, which is...
Are you sure they're not? I mean, they looked at 14,000 studies, and if they're talking about sea level rise, and they're talking about, I mean,
yes.
they absolutely, there are studies that have been done, so they know that ice weighs down land. When you remove that weight, the land's going to move up, but they're also, they're calculating the water going into the oceans. They're also trying to calculate the thermal expansion of the water. So they're definitely... So it's not going to be completely homogeneous around the entire globe. It's going to be different in different places.
Yeah. So if they do have that data, I didn't see it shared. So if they did share the disproportionate effect on what is mostly what we would call the third world nations and Florida, same thing. I haven't seen that in the report. I haven't seen the report expressing how much more it's going to affect sea level rise on equatorial nations. I haven't seen that anywhere in there. But that's also to say that with all of the scientists that they have involved and all of the things that they have addressed and looked at this point, there's still a ton more data that feeds into this system that is unaccounted for. As has been every iteration of the IPCC
every report.
We keep adding to this knowledge base, and then we're going to watch. We're going to stop predicting and get to the point where we kind of are already now, where we're doing observational reporting on these effects.
Harrenlore, oh my goodness. Harrenlore is asking, if the ice caps melt, can we get access to all that hidden fossil fuel? And if so, how much cheaper will our stuff be? So that's part of the problem. Yes, if the ice caps, if the Arctic becomes completely open, there's a ton of gas and oil underneath there. The U.S. and Russia there's going to be conflicts because of it. There already is. I think, we're like trying to stick our flags on the bottom of the ocean right now, staking claim to these gas and mineral reserves. Yes, it would be easy to access-ish. It's under the ocean, so not that easy to access, but not good. Not good at all to continue to heat the planet. So no, we need to tell the gas and oil companies, no, you can't go there.
So I'm actually...
Leave that fossil fuel alone.
So this is sort of... I joked about this in the disclaimer about the fact that the fossil fuel industry, nobody will ever be held accountable. No corporation, no individuals, nobody who knew but still acted in the interest of profit over entire well-being of humanity will ever face consequences.
No, because we have a capitalistic society and they were just doing what capitalism was telling them to do.
Nobody in the tobacco industry...
Go forth and prosper.
Nobody in the tobacco industry
leaving
ever went
destruction
to jail
and death in your wake.
Despite,
if you can, you should.
Hundreds of thousands of people being dead. Right? But now we're here in real time. We're here in real time. I think you should compare the death toll in Florida to a comparable state and make a charge of manslaughter at the very least on that many cases to what's his name? What's the Florida guy? That's Santos?
Florida man. We're just gonna call him
Florida man.
Just Florida Man.
I think we should charge Governor Florida Man with, tens of thousands of cases of manslaughter. Because that's what he's doing is amounting to that. And also the Abbott in Texas. They are willfully, and I'm telling you, Republicans do things with a motive. That's all politicians do. All politicians do. But the Republican
All
Party
politicians
is really,
do things with a motive, and
Yeah,
as long as
the
there's
Republican
money in
Party-
politics and politicians
Sure.
are able, after they're in
Yes.
office, to invest without insider trading conflict
the
of
least of it.
interest, come on, man. And they've got the lobbyists who are I'll give you the money if you do this for me, and then suddenly you have millions of dollars going back into the pockets of
Yeah, but certain the
already
Republican
rich
Party
people.
has sort of branded itself
$5.
as the corporate front for a lot of things. Big Oil has been one of their sponsors for many, many, many years.
Yeah.
Big Tobacco before that was the thing too. Who is sponsoring these politicians through this COVID? Or at the very least, not backing away. Not telling them, because of what you're doing, we're withholding funds. I feel like there has to be a profit margin
Russia.
somewhere.
No, there was somebody suggested that the lack
never had that kind
of
of
the
money.
lack of mask mandates for school. There were comments on Twitter that what was happening in Texas, I didn't see related to Florida, but could potentially apply, that the steps that were being taken to not protect children in the schools could possibly be seen as a ploy to help with the dismantling of the public school system, because they don't really want a public school system anyway. So
Awesome. Who needs that?
no proof whatsoever. This was a comment that somebody made on Twitter.
Well,
And I was
it's not like we need a public school system, because it's not
There's
like
some
we
thought.
have public understanding that is lacking, that is currently affecting public health, that would prove that you would need a better public schooling system.
Yeah,
Right,
and there's also
the
the
feedback
idea
loop.
that people who want their worker caste system to go back to work know
Yeah.
that worker caste can't afford childcare and needs to put them in school. And
So they
wants
have
them
to
Yeah,
have the
that's
schools
what I
open.
wrote in the
explain
chat
no
room
masks.
earlier.
But that still doesn't explain that explains opening the schools, but it doesn't explain the no mask. I almost feel like there is an interest that wants this virus to infect and kill more people. And there's a profit behind it. There has to be. And the only thing I could think of, and I'm probably just out on it because it's my one thing that I'm always hyper focused on, is housing. If we've lost hundreds of 500,000 people, how many homes is that? And then you have how many foreclosures that are taking place? It's recreating the housing crisis, and the only people who really profited massively, gigantic transfer of wealth from the housing collapse was Wall
Blackstone
Street.
is gonna
Blackstone, companies like this, but Wall Street,
statistically, the majority of
institutional real
people
estate
who
investments.
statistically the people who died of COVID don't own homes. I'm just gonna put out there. So
Yeah.
that's kind of the problem with that argument.
But they're pushing it for a whole sect of people. But
Yeah.
But so here's the thing.
Interesting thing that was found, though, actual people really trying to move things around. The report that a UK front company that called itself, it was a marketing company, but it's basically a front for a Russian organization.
Cambridge
I don't know,
Analytica?
marketing, was putting out marketing campaigns that were trying to show that the vaccines, doing misinformation and disinformation campaigns about vaccines. And they recently got caught by Facebook because they were trying to recruit influencers to help them with their misinformation campaigns, and the influencers reported them. And so that's the only way that Facebook caught them. But it ended up because of the trail, they ended up discovering that this group wasn't only trying to get influencers to help spread misinformation, but had a whole bunch of accounts and bot accounts that were on all the social media pushing a bunch of really ridiculous ideas that people were constantly making jokes about, but they were just putting them out there. So
yeah, but I mean, there has to be anybody who's against people protecting themselves and pushing this has to have an agenda at this point. Has to have a payoff for it. Now it can be an opportunistic because somebody has sold this many dupes on this, and I can run off of that as a politician. That's also possible from the political side.
Bad press is still press, and people.
There's bad press, and then there's like kids are dying.
I know. I don't understand.
As simple as it aggravates and enrages and activates a particular group of people that can also be profited upon. I really think it's that simple.
Yep.
Is that you are activating a group of people that you can manipulate to further use.
Yeah, but further use to die. Like, get sick and die, and then not be able to, like, get kicked, lose your home. This is why, like, the home is the biggest thing that can get flipped in any of this. Nobody
but they're
wants
mostly
this
renting.
crap
This
in
is
their
the
garage.
thing. Most of them are renting, and
That's
yes,
not true.
because
That's
the
not true.
majority of
Look,
COVID deaths were lower socioeconomic levels.
Yeah, but you're forgetting this is Florida. The houses have been priced at lower socioeconomic levels. So
there's still a huge barrier to home ownership.
63% or 64% of Americans own their homes. 500,000, 600,000 people, maybe it's more now, are dead. So now you're talking about maybe 300,000 homes, maybe 200,000 homes, somewhere in that range. I don't think it's
directly. You're assuming it's a direct percentage, and it's not. If half of Americans own homes, not a uniform distribution of people died.
But you got to look at who is. I mean, there are people who won't vaccinate.
I think this is
they're not.
I think this is an interesting direction, but I don't think that we have. This is all speculation, and it's just.
This is why we're doing it in the after show.
Yeah, but it's all speculation. And
I mean, if we're gonna speculate, I really think it's all a political thing. I really do. I think they're trying to push and activate a group of people
there is such a thing as
to change over what happened.
Both views could be correct as well because
we have a moderator.
Yes, I'm moderating.
We have a moderator.
I mean, there's no reason to think that there might not be multiple bad actors with different driving forces behind them, right? Like there could be just the political actors. There could be the ones that are out there trying to make money off of specific things. There probably are. I mean, there are.
That'd be a big chunk of money.
Yeah, the people who are continuing to push this particular thing. So there's the anti-vax 12. Have you heard about that? Where there are 12 people that have been specifically linked with vaccine mis and disinformation. Like 12 accounts, 12 people, 12 groups that have been specifically linked. And now it's like because people are tracing the data, they're able to go back and go, hey, these 12 people. And when something happens, it's the same exact people, it's the same exact groups that are saying the same exact things over and over again. So the question is, let's go back to those people, find out where their money's coming from. What exactly has happened to keep them. Are they just doing it because they like the attention?
Could be.
Or
they could be think tanks.
Yeah, there's a Canadian anti-vax woman who she definitely profits off of it for her personal business. And so, yeah.
Mm-hmm.
So there's sometimes not just the bigger gain, but just individual personal gain too. People are fascinating beasts.
I don't like a lot of them.
I like a lot of the people who are in
so
our chat
disappointed.
room right now, who are
love all
watching,
of
who are
them.
hanging out with us. I like the people on the screen with me right now.
But I gotta go. I was up. I'm about to do the full 24, and I don't want to.
Ooh, let's keep you up until 3:30 in the morning.
Oh, thank you.
Yeah,
So-
Lauren, no, I want to stay. Yeah, no conspiracy. I'm trying to stay away from the conspiracies, even in the after show. We can
Oh, wait, we
speculate a
haven't-
little, but I gotta bring it back. Bring
I'm
it back
trying
to the
start
facts.
one of those things where we become the center of a controversy and we can spread information. That's really profitable. But we don't have a way to make money, though. That's
No,
the
I don't
thing.
want
We
to. I
haven't
don't.
ever figured
I
that out.
would prefer not to get kicked off of social media platforms. So let's make continuing to talk about fact and what we know, science, curiosity. Let's try and keep that going. Blah. There's a lot of stuff out there in the world right now, everybody. We're going to help
All
you
right.
wade through it, I hope.
Say
What do you have
goodnight,
to say
Blair.
right now? Yeah.
Say goodnight, Blair. Goodnight, Justin. Nope, did it wrong. I'm tired.
Then
Night,
say goodnight,
Say
Blair.
goodnight, Justin.
Good night, Justin.
Good
Whenever you're ready.
night.
Good night, Kiki.
Good night, everyone.
Oh no.
Oh no, everybody's so tired. Blair really needs to go to bed right now, obviously. Go love your Sadie. Don't fall down right there, Blair.
Good night,
You look like you're just going to go
See you
bloop and
next
fall
week.
over. Good night, everyone. Thank you so much for joining us. We hope that you stay safe, stay well, and stay curious. Stay sciencey until next week. We'll be back with more This Week in Science. Thank you so much for joining us tonight. Bye.